All right, hi everybody. So, welcome. Thank you for joining me on kind of a breaking news live stream. So, this is to go over the Vera Rubin telescope images that were just unveiled. So, this is something that I guess I didn't quite understand the schedule. The images were actually unveiled like 11 p.m. last night US time, although, or at least that's when I saw like the first article was about 11 p.m. Central Time. So I think they were like unveiled late last night, depending on where you are in the world, and then the press conference was this morning. But still, very, very interesting. Definitely something I wanted to discuss. So let's talk about this. So, first of all, I guess we need some context, right? So, where is it? So that's not what I wanted. That is also not what I. There we go. Okay. So this is Vera Rubin. So who the telescope is named after. So who is Vera Rubin? So Vera Rubin was an American astronomer who pioneered work on galaxy rotation rates. She also came up with strong evidence, some of the first evidence, not the first evidence for dark matter and dark energy. So very, very strong evidence that there was something out there that we weren't sure about. We still, it's hard because obviously we haven't discovered it yet. That's just our name for it. But there certainly is conclusive evidence that there's something else out there, some other sort of matter, for lack of a better term, maybe. So that's Vera Rubin, and so yeah, she did some really great things in astronomy. So she actually, it's interesting, she taught mathematics and physics at various universities as well and did a lot of research, including at the Carnegie Institution. And so she made a lot of good advancements, including with spiral galaxies, particularly the Andromeda galaxy. That was one of the ones that she studied with the and came up with what was known as the Rubin Ford effect. So that was with Kent Ford, who she was kind of studying all this stuff with, or a lot of this stuff at least, during this time with Kent Ford. So she did a lot of great work, particularly on when it comes to motion in the universe, galaxy motion, all of that. For instance, she investigated the rotational curves of spiral galaxies, again, beginning with the Andromeda galaxy. So let me just check the chat real quick. Ew, why didn't it say I'm live? Okay. Let me see. There we go. So that's some about Vera Rubin. And so let's talk about just kind of all of the circumstance around this telescope, kind of some background, right? So this telescope, first of all, let's talk about James Webb. So this Vera Rubin telescope is really the biggest telescope. I mean, biggest in terms of, well, like actual size, but also like just impact or potential impact. It could do great things, and we've, again, as I said, as we're going to discuss later on in this live stream, we've already seen some incredible things. So let's... Why? That's disappointing. Okay. Huh. Okay. So the James Webb Space Telescope. I guess I will have to get another image. I was not expecting that. I had an image there, and it is obscured for some reason. So let's get another image right quick. There we go. I don't know why the other one was not loading properly. But here, I'll make it big for a few seconds, just so you can look at it there. So that is the James Webb Space Telescope. And the James Webb Space Telescope has also made some really incredible discoveries, particularly around a lot of the same things, galaxies, the rotation and expansion of our universe, as well as seeing extremely far, farther than we've ever seen and farther than a lot of people thought possible in terms of how far back we can see into the early universe. It's gotten to within like 300 million years of the Big Bang, or what we call the Big Bang, however that happened. So, although that's scientifically accepted way, so let's call it that. So Vera Rubin is just building on more of what James Webb did, which is really fascinating. So before let's talk about, well, actually, for some more background, let's talk about some stuff that James Webb has discovered about galaxies. So it's discovered a large number of ancient galaxies, a larger number, far larger than we thought should be there. It's also discovered, as I said, some of the earliest ones ever observed, which is pushing back the timeline of the known timeline, or what we thought we knew, of galaxy formation. For instance, so these galaxies observed just as they were just hundreds of millions of years after the Big Bang show complex structures and star formation, which challenge a lot of the existing models of galaxy evolution. So James Webb identified hundreds of ancient galaxies dating back to within the first 300 million years of the Big Bang. These galaxies are also much more numerous than previously thought, which suggests that galaxy formation could be more rapid and efficient in the early universe. So that, again, that kind of ties in with that whole universal expansion about we don't know how fast these are happening, but like the expansion, for instance, seems to be happening faster. So maybe it like happened really fast early on and then it slowed down, which would make sense because the universe at the start was extremely hot, and so it would make sense that the expansion, formation, all of that slowed down as everything cooled down. We don't know that for sure, but we'll see about that. Also, the telescope's observation, James Webb, showed these very young galaxies, even the galaxies that were very young that had already complex structures and active star formation, which indicates that there's far more dynamic and the early universe evolved far faster than maybe previously thought. This challenged a lot of the early models as well, so they're reevaluating those, obviously. I mean, we're always reevaluating stuff in science. And then it also discovered things like, saw early black holes, early universe reionization, it detected dust, and it looked at spiral galaxies in the early universe. So lots of exciting stuff there. So, and then that gets us to Vera Rubin, the Vera Rubin Telescope. So the Vera Rubin Telescope officially began construction on August 1st of 2014. It was formerly known as the Large Synoptic Survey Telescope, LSST. It was renamed the Vera Rubin Telescope. And that just indicates, that marks the point when the National Science Foundation authorized the first portion of its construction budget. So that was the Vera Rubin Telescope. So now let's look at these images. So this is the first one here. How do we get rid of that? There we go. Okay. So this is the first image here. Make it bigger real quick. It's a really, really big image. Yeah, wow. So yeah. So really beautiful image. It's really cool, all of the different things that you can see about the galaxy formation. There's a lot of early spiral galaxies, and there's a lot of galaxies that are super close together as well. So let's talk about that real quick. So these galaxies that are very close together, they were very close together in the early universe. So, and then obviously as it expanded, they grew further apart, right? So that's why we see in certain parts of the sky all of these galaxies that are super close together, because we're seeing extremely close in cosmic terms to the Big Bang. So that's just so super fascinating. And it's also just a beautiful image. I mean, look at all that color there. The sky is beautiful. So that's fantastic. So that was the first image, and then down here, no. Oh no. Okay. So there it is. So those were lots. So the first image is lots of galaxies, and this one so this is a composite of the Trifid and Lagoon nebulae, which that resolution is just absolutely stunning. That looks gorgeous. So that's awesome. It also, oh, that's what that is. So, and then that first image is the Virgo cluster. So the Trifid Nebula, which is named for the three lobes that were separated by the dark dust lanes of Bernard 85, and that intersect at its center. It's located at the upper right. So, like around there. And then the much larger Lagoon Nebula, which is a well-known star-forming region, glows to its lower left. So that's this area right here, the like pinkish white right there. So both nebulae are located some 5,200 light years away in the constellation Sagittarius. A light year is 5.9 trillion miles. So yeah, 5,865,696,000,000 miles, or 9,460,800,000,000 kilometers. So a very, very long distance, obviously. So that is that image there. So yeah, so that's some really interesting stuff. Those are just the first images. They've already learned a lot, and it's going to be super exciting to see what they see in the future with that. So I guess lastly, let's look at what they might look at in the future. So the way that it observes is it will scan a portion of the night sky every like 3 nights, and that's what it does. And so that's how it goes about observing the sky. So hopefully, like there are a lot of great things that it's going to do. Hopefully it really transforms astronomy. So on a typical clear night, for instance, at 2,650 meters, which is the elevation of the Vera Rubin telescope, and the telescope itself is 350 tons. A ton is 2,000 pounds, so that's like 700,000 pounds, which is really heavy. So there's just a lot of really fascinating technology in this. So it has a field of view as large as 45 full moons. Every time it stops, the 3-ton car-sized camera will record the view with an array of 189 light sensors that are cooled to minus 100 degrees Celsius, which, for context, would produce an image so rich it would take a wall of 400 ultra-high-definition TVs to display it. So this article that I'm looking at is from science.org, by the way, if you want to check it out. So, and then each snapshot is 30 seconds, and it will slew, which is just basically just to navigate to another destination in less than 5 seconds. So that's some of the technology behind it, and there's a lot of interesting stuff here. So like, for instance, it's going to produce alerts for each new transient, which I guess is just like each new object. Not quite sure about that. Oh yeah, here it says, yeah, as many as 10 million a night. So, and millions of new asteroids and other objects, which another headline also was that it's found already thousands of asteroids. So that's fascinating. And the alert system is going to try to exclude streaks left by the growing fleet of satellites orbiting Earth. So there's this whole other discussion also about the role with the new, all the Starlink and these different satellites, and a lot of complaints from astronomers about how they're impacting the night sky, because they are, because you look at like a night sky and you just see a lot of these streams of satellites. So, and it also really, it brightens up the sky and it harms the astronomers' images as well. So it is an issue, and it's something that like SpaceX and other companies are working on as well. So we'll see how successful that all is. So that was just a quick overview of the Vera Rubin telescope. These images are super exciting, so I'm really glad that I was able to cover this. They are also going to do, they highlight this big survey they're going to do. So, for instance, this vast archive, which is going to grow by like 20 terabytes each night, which is a lot. And after a year, it will contain more optical astronomy data than that produced by all previous telescopes combined. That survey is going to begin in about 6 months. In the meantime, the staff are practicing all the steps needed to produce images at night, every night for the next 10 years. So that's supposed to be the life of the telescope. So the first test images, okay, yeah, it says were revealed today. This is an older article. So yeah. And then that's just, it will be fascinating to see, and that's something that I'm definitely going to be covering further on this channel. So Tony Tyson, who is an astronomer at the University of California, Davis, and the chief astronomer for the Rubin Telescope, chief scientist, I guess, he said the inspiration for this observatory came to him more than a quarter century ago, when he was sitting in the control room of another telescope in Chile. At the time, he worked for Bell Labs and was studying dark matter, which guides the formation of galaxies and dominates ordinary matter by a ratio of nearly 6 to 1. So far, we don't really know anything about it, just that it exists, because astronomers can only detect it through its gravitational effects. So we don't have anything that can really directly see it yet, just the effects. So Tyson wants to map the distribution of dark matter from the way its gravity distorts images of more distant galaxies, which is a technique known as weak gravitational lensing. However, the photographic plates astronomers had long used weren't sensitive enough. So that was an obstacle that they had to overcome with this. So Tyson and others tweaked an earlier Bell Labs invention, charge-coupled devices, or CCDs, which are semiconductor arrays that convert incoming photons into electrical charges that can be read as an image. They also built chips packing in more and more pixels until they produced one with 4 million of them, or 4 megapixels, which is modest for a digital camera today, but was a staggering figure then. By 1996, Tyson and his collaborators had built the big throughput camera with 4 of the chips and installed it on the Victor M. Blanco 4-meter telescope, some 15 kilometers from where Rubin now stands. So while he was in Blanco's control room, he realized that the search for dark matter would be more efficient with a big wide-field telescope, which captures light from a huge swath of sky at once and focuses on a much larger array of CCDs. So that's when he teamed up with Roger Angel, who is an astrophysicist at the University of Arizona, who has built mirrors for some of the world's largest telescopes, including the Giant Magellan Telescope, which is a large telescope, super large telescope, now under construction that uses 7 giant mirrors as a single reflector, 25.4 meters across. So none of the individual mirrors, though, are larger than 8.4 meters, because the glass from which they are made, they're cast and polished, and it's cast and polished in a laboratory underneath the University of Arizona's football stadium that is blockaded by concrete pillars at regular intervals. So he says if you made the mirror much bigger than that, you wouldn't be able to get it out. So Tyson's vision required a fast and compact telescope with a wide field of view. Angel's solution was to use 3 concentrating mirrors rather than the usual 2. The main 8.4 meter reflector incorporates 2 of them, a ring-shaped primary mirror surrounding another mirror polished in a different shape. A separate convex mirror faces those 2. So that's an overview of the Vera Rubin Telescope. Some really interesting engineering there as well, and hopefully it finds some good stuff. But I will definitely, here we go. Okay, so I will definitely be updating this more as this whole story progresses. But thank you for joining me for this live stream. This is really fun to cover. Make sure also that you check out the other live stream I did a couple days ago about all of the SpaceX news as well. I'll have that linked in the description box down below. And I will be doing another live stream this week, Friday or Saturday. That will be my 1,000 subscriber live stream. So thank you for subscribing. Definitely subscribe for this and future live streams and videos if that is something that you are interested in. So share your thoughts down below. What did you think about all these images? What do you think it might discover? What are you interested in with this? So share all those thoughts down below. Subscribe today, and I will see you in the next video or live stream. Thank you so much for watching. All right, bye.